Let's talk a little bit about the coefficient of static friction activity that we handed in with your Newton's laws packet. This is where you plotted force of friction versus mass, and then of course we always relate graphs to equations. We saw that this relates to y equals mx plus b. We found the slope as being the coefficient of static friction times g, and then from that we found an expression for the coefficient of static friction. Great. But then I did ask you in the analysis section what else you could plot. So I'm going to go through some of the examples. And most students were just fine on this. Most students chose they're going to plot, for example, force of friction versus mg. So looking at the equation, and they see, of course, they make it look like y equals mx plus b. In this case, the slope would just represent mu sub s, and that's absolutely fine. And then other students said, I'll plot force of friction versus normal force, which in this case is the exact same thing as force of friction versus mg because it was on a level surface and mg was just equal to n. So that's great. Those are all very good ways of doing this. But then there's a couple other answers that students are giving where you have the right idea that looking at the equation, manipulating it in some sort of algebraic way, but let's go through why it doesn't quite work. So for example, some students did force of friction versus mu sub s. So they said they would plot that. So think that through for a second. Maybe pause the video and think why this would be a way that wouldn't work at all. Well, I know it's been a while since you did the activity, but recall the whole point of the activity was to calculate mu sub s. Remember, you didn't know mu sub s. So if you were to try to plot the force of friction versus mu sub s, well, good luck. You don't know what mu sub s is. Plus, of course, mu sub s doesn't change, right? The whole point of plotting things on a graph is that one variable changes, the other variable changes, right? So students who did this, you have the right idea. You're looking at the equation and realizing, you can sort of manipulate it that way. In this case, I guess the slope, and here I'm using air quotes, the slope would be equal to mg. But again, mu sub s doesn't change, and we didn't know mu sub s, so this just doesn't work. So you have the right idea how we manipulate equations, but now you have to apply it. You have to take it to the next level and see, well, does that actually work with the actual experiment we did? And then other students, they plot force of friction versus g. Take a second and think about that one. Okay, again, for the same reason, this won't work because g doesn't change, right? What would this actually look like? Well, it would look like this, right? Since g never changes, you get all these different force of friction to get a vertical line that's completely meaningless. And so again, here's students who are getting the right idea. They're looking at the equation, they're seeing what else they could plot, but now we have to take it to the next level and make sure it actually works with the experiment we're actually doing. And then, of course, my favorite one was this, sine theta versus cosine theta. Okay, so here's students who are thinking about what we actually did, and we watched the video where I raised the angle of the incline larger and larger, and we had that angle there where it just barely was held on and then started to slip down the incline, and so I guess you could take different angles there, but in the end, remember, we didn't do that. In the end, we really just found one angle because this only works when we set the force of friction equal to the maximum value mu sub Sn, and then we derive the equation for how theta could be equal to the inverse tangent of mu sub s, right? It only works at that one point. So if you were to plot sine theta versus cosine theta, since we only took one angle, what would that look like? Well, that would be this, right? That wouldn't be a line at all. So again, we're getting the idea. Students are thinking about the equations that relate to this and think about different relationships. So you're at that level. And now I need everyone to get to the next level where now you apply it to the actual experiment being done and seeing if what you plot actually makes sense.